So we'll review the concepts from sections 1 through 3 of Module 5 in preparation for the quiz. So in section 1, we talked about whether or not something was a rational expression and then values that could be excluded from the domain. So if you remember, when we're just dividing fractions in general, we cannot divide by 0. So when we're trying to figure out the values that are excluded from the domain, we solve for, that's not how you spell for when denominator equals 0. So in this problem, we have x plus 2 over x squared plus 8x minus 9. So we're going to take x squared plus 8x minus 9, set it equal to 0, and solve. So in this case, in solving for when it equals 0, we have to factor. So our numbers that multiply to -9 and add to 8. So there's only 2 ways to multiply to 9, 3 and 3 or 1 and 9. And the only way you're going to add to 8 is if you have a positive 9 and a negative 1. Now we'll take each factor, set it equal to 0, and solve. So we have x plus 9 equals 0 and x minus 1 equals 0. So we'll subtract 9 and we'll get that x cannot equal -9. And we'll add 1 and we'll get x cannot equal 1. It is important to remember the does not equal symbol, because these are the values we're excluding, so these are the values that x cannot equal. The last thing we covered in section 1 was simplifying rational expressions. So that means factoring the numerator and denominator and canceling or simplifying anything they have in common. First example, we have 4x squared minus 10x minus 6 all over 2x squared plus 5x plus 2. Anytime the number in front of x squared isn't 1, I'm always going to check for a GCF first. And in our numerator, we do have a GCF. We have a GCF of 2. So I'm going to factor out the 2, and we're left with 2x squared minus 5x minus 4 all over 2x squared plus 5x plus 2. Next thing we want to do is factor the quadratics in the numerator and denominator. What I would like you to do is to pause the video, work through the box method on your own, and then check to see if you end up with the same factors as I did. So our numerator is going to factor, as we still got to remember our GCF 2, and then in parentheses we're going to have 2x plus 1 and then 2x minus, made a boo-boo. This should be minus 3, not minus 4. So it's going to be 2x plus 1, 2x minus 3. Not 2x, just x. There we go. Now it's correct. So you should have 2 parentheses 2x plus 1, x minus 3. And in the denominator, factors as 2x plus 1, x plus 2. Now we want to cancel anything that is identical that's in the numerator and the denominator. And both of them contain a 2x plus 1. There's no numbers to simplify, so our final simplified answer is 2 parentheses x minus 3 over x plus 2. And we always leave our answer completely in factored form. We're never going to distribute back into any parentheses. We could also have a problem like number 3. We're just simplifying two monomials in the numerator and denominator. So we have 45x to the 5th, y to the 7th, all over 60xy to the 34th. So I'm actually going to break this up to simplify each part. So 45 over 60, x to the 5th over x, and y to the 7th and y to the 34th. When we have a monomial like this, the simplest way to simplify it is to break it up and look at each part that's going to simplify. So I'm first going to start with the 45 over 60. So I want to find the biggest number that goes into 45 and 60. And 15 goes into both of these. So 45 divided by 15 is going to leave us with 3. And 60 divided by 15 is 4. Next, we're looking at x to the 5th and over x. So remember, we can think of x to the 5th as x times x times x times x times x. In which case, there is one x that we can get rid of from the numerator, so it becomes a 4, and then the x in the denominator goes away completely, and we're just left with 1. And then we have y to the 7th over y to the 34th. Now I'm not going to write out all of those y's, but we can do the same thing we did with the x's. There are 7 total x's that I can get rid of in the numerator, leaving with 1, and then it'll cancel and leave us with 27 y's in the denominator. So now my final answer, I'm going to multiply back everything in the numerator. We have 3 times x to the 4th times 1. So we'll have 3x to the 4th. And in the denominator, we have 4 times 1 times y to the 27th. So we have 4y to the 27th. And that is our simplified answer. In section 2, we looked at multiplication and division. Now, I'm going to do 2 examples of division because division ends up turning into multiplication anyway, so they're pretty similar steps. So the first step when dividing is to change the problem to multiplication. Okay, and the way we change it to multiplication, we leave the first fraction alone, so 6x minus 15 all over 5. We change it to multiplication, and then we flip the second fraction, 2 over 3x squared minus 27. Now it's a multiplication problem, where we just factor and simplify. So 6x minus 18 has a GCF of 6, which I can factor out and leaves with x minus 3 in parentheses over 5 times, we have our 2, 3x squared minus 27 also has a GCF of 3, which then leaves us with x squared minus 9. Okay. I'm not quite done factoring because I still have a quadratic. So you can't start simplifying or canceling anything until you don't have any more quadratics. So I'm going to leave the first fraction alone for now. And my second fraction, we're going to have 2 over and then 3, and then x squared minus 9 is a difference of squares. It's going to factor as x minus 3, x plus 3. Now I can start cancel and simplifying. So first I notice that I have an x minus 3 in the numerator and denominator that I can cancel. Next I want to see if there's any numbers I can simplify. And I can simplify 6 and 3. So 6 is divisible by 3 and it becomes a 2. And 3 divided by 3 becomes 1. So when I multiply what's left in the numerator, I have 2 times 2, which is 4, over 5 times 1, which is 5, and then in parentheses, x plus 3. And there's no more simplifying I can do, so that's going to be the final answer. Next, we have 2x plus 10 over x minus 3 divided by x squared plus x minus 20 all over 3x squared minus 12x plus 9. So again, our first step is going to be to change it to multiplication by flipping the second fraction. So 2x plus 10 over x minus 3 times 3x squared minus 12x plus 9 over x squared plus x minus 20. Yep. Now I want to start factoring. So 2x plus 10 has a GCF of 2, which leaves us with x plus 5 in parentheses over x minus 3. Before I use the box method on 3x squared minus 12x plus 9, I'm going to check for a GCF. And there is one in this case. 3 goes into 3, 12, and 9. So I won't actually have to use the box method, because once I factor out that 3, I'm left with x squared minus 4x plus 3 in parentheses, which has a leading coefficient of 1. And I'm going to save to factor the x squared plus x minus 20 for the next step when I also factor the numerator quadratic. So I'm going to leave my first fraction alone, 2 parentheses x plus 5, x minus 3, times, and I have my GCF of 3. So now when I'm factoring my numerator, I'm looking for the numbers that multiply to 3, but add to negative 4. And that's going to be negative 3 and negative 1. So there's only one way to multiply to 3, 1 and 3. And the only way for them to add to negative 4 is to both be negative. And then in my denominator, I'm looking for the numbers that multiply to negative 20 and add to 1. Okay? There are 3 ways to multiply to 20. 1 and 20, 2 and 10, 4 and 5. But the only way you're going to get those to add to a positive 1 is if you have a positive 5 and a negative 4. I'm now ready to cancel any factors and simplify any potential numbers. So I see that I have the factor x plus 5 and x minus 3 that I can cancel. And that's going to be it. So when I write my final answer, I have 2 times 3, which is 6, and then in parentheses x minus 1, over, and then the only thing in my denominator is x minus 4. And again, I'm going to leave it completely factored. So the last thing we're going to look at is addition and subtraction. So you're going to only add and subtract rational expressions if they have common denominators. Okay. So in our first example, we have 4x over x plus 5 minus 5 minus x squared over x plus 5. So both of them, I have common denominators here, so I don't have to multiply by LCD. So I'm going to go ahead and write it as a single fraction. So we're doing 4x minus, in parentheses, 5 minus x squared all over x plus 5. Now I'm going to distribute that negative into the parentheses. So we get 4x minus 5 plus x squared all over x plus 5. Now, since I have a quadratic, I'm going to reorder it so it looks like a regular quadratic. X squared plus 4x minus 5 all over x plus 5. If I have a quadratic expression left in the numerator, I want to double check to see that it doesn't factor and therefore simplify my fraction anymore. So it could mean factoring a GCF sometimes, but in this case it does mean factoring a quadratic. So if I'm looking for numbers that multiply to -5 and add to 4, and there's only one way to multiply to 5, 1 and 5. And there is a way for those two numbers to add to 4. And that's if we use +5 and -1. So when I factor it, I get x plus 5 times x minus 1 over x plus 5. And I do actually have something that will cancel, which is the x minus 5, leaving me with x minus 1. So after you add or subtract, even if you already had common denominators, you want to look to see if you can simplify it any further by factoring a quadratic or factoring a GCF. Okay. Our last example, we have 2 over x minus 4 minus 3 over x plus 6. So we don't have common denominators here, which means we're going to have to find our LCD. And since each denominator is a single expression, the LCD is both denominators, x minus 4, x plus 6. I now need to multiply each fraction by the expression it's missing out of the LCD. So 2 over x minus 4 is going to get multiplied by x plus 6. And then 3 over x plus 6 is going to be multiplied by x minus 4. Now what we need to do is distribute into each of those parentheses in the numerator. So 2 times x and 2 times 6 is going to give us 2x plus 12 over x minus 4, x plus 6, and minus. Then we're going to do 3 to x and 3 to -4. And we're going to get 3x minus 12 over x minus 4, x plus 6. And because it's a subtraction problem, I'm going to go ahead and write it as a single fraction like we did in the previous example. So 2x plus 12 minus, and then in parentheses, 3x minus 12. Then our denominator, x minus 4, x plus 6. Now I'm going to go ahead and distribute that negative. So we have 2x plus 12 minus 3x plus 12 all over x minus 4, x plus 6. And now I can combine like terms. So 2x minus 3x is going to give us -x, and 12 plus 12 is going to give us 24 all over x minus 4, x plus 6. And there's nothing I can do to simplify this any further, so this is going to be the final answer. Let me know if there's any questions you still have from sections 1 through 3 before taking the quiz.